You finish a manual QA session for a new AI feature. You tested the happy paths, the responses read well, and nothing broke. You mark it ready for deployment. It feels like a solid validation pass. But language models do not fail by crashing. They do not throw exceptions or return null errors. They fail by being confidently wrong, slightly off topic, or quietly toxic in edge cases nobody thought to check. A standard manual walkthrough will miss every single one of those internal fractures. To catch them, you need to replace manual sessions with a fully automated evaluation framework, and you can set it up in 5 business days. This setup will take your system prompts and run them head-to-head against a curated dataset, exposing silent failures before they reach production. Relying on the general feeling of a successful manual test is a liability. User trust requires a validation framework built on hard data. Day 1 starts with picking the right tool. The correct choice depends entirely on what your engineering team is already comfortable using. If you have a Python-heavy team doing deep analysis of a retrieval pipeline, DeepEval is a strong candidate. But if you want fast, continuous integration, you look at PromptFoo. This diagram illustrates the split. PromptFoo relies on YAML configuration and integrates natively with continuous integration systems. That makes it much faster for SDETs to deploy directly into an existing pipeline. The most effective evaluation tool is the one that maps naturally to how you ship code. Before you configure any tools, you need a ground truth dataset. This step will consume your first 2 days, and it matters more than any other decision you make. You build this dataset from 3 sources. First, you pull anonymized production logs. These capture real user intent, which is far more valuable than what the team assumes users will ask. Second, you write adversarial prompts. You deliberately craft inputs designed to trigger toxicity or push the model outside its knowledge scope. Third, you add regression tests. Look at historical AI bugs that previously reached production and add them to the permanent dataset. Now, when defining the expected output for these 120 test cases, do not use exact string matching. Language model outputs naturally vary. Instead, define expectations as specific criteria. Outline the exact claims the model must make, the sources it must cite, or the claims it must avoid. When you combine real queries, edge cases, and semantic criteria, you turn an unpredictable text generator into a set of highly measurable test cases. This visual displays the 4 specific metrics required to evaluate AI outputs. To allow for natural language variation, we apply semantic similarity thresholds to each one. The first is answer correctness. We set the threshold at 0.85. This ensures the model's factual accuracy matches the ground truth output without demanding a word-for-word copy. Next is context adherence. This is a hallucination detector. It verifies that every claim in the response comes strictly from retrieved documents, not the model's internal memory. Finally, we measure toxicity to catch harmful edge cases and response consistency, which ensures that different phrasings of the same question yield the same factual answer. By combining these 4 specific metrics, the framework covers the exact blind spots that human testers miss during manual sessions. On day 3, you write the PromptFoo YAML file. You will configure 3 main sections: providers, prompts, and tests. This diagram shows the required routing. You must point your provider at your full API endpoint. You are testing retrieval and generation together, not just the language model in isolation. Next, you stack multiple system prompts in the YAML file. This allows you to run your current production prompt alongside new variants simultaneously to see which performs best. By day 5, you integrate this setup into GitHub Actions. It takes exactly 4 lines of configuration code and your environment secrets to run the entire evaluation. Configure this CI pipeline to automatically fail the build if any of the 4 metrics drop below their defined thresholds. Once deployed, this integration acts as an uncompromising gatekeeper, physically blocking degraded AI models from ever reaching your users. When you push the 120 curated queries through the full API on your first automated run, the results are immediate. In our case, the automated pipeline caught 14 subtle regressions that manual review had marked as passing. These were not catastrophic, obvious errors. They were plausible-sounding responses that omitted a critical piece of information. They sounded perfectly fine to a human tester. This side-by-side table shows the head-to-head prompt comparison. The revised system prompt scored a 15-point improvement in context adherence over the production baseline. Keep in mind, those 120 queries are just a baseline. The dataset is a living document. You must update it every time a new edge case surfaces in the wild. Implementing this framework removes impressionistic debates from sprint reviews. Instead, you make decisions based on hard numbers.